We're going to try to understand where and how we're going to break this down so that those floors exactly match the outline of my building in all cases, right? What's really helpful about this is that anytime you have anytime you create the boundary of the floor plate, you know that that's where you need it to be modified. Are you guys talking about design?
No, I'm sorry. Not even.
All right. This stuff is important because it is going to get really complex really fast. I know it's super simple right now, but it won't be forever. So anyway, this boundary is creating the bottom plate, and then we moved it up in order to generate the actual volumes, right? So the concern that we have is that I could theoretically twist each one of my floors to get it to match, but what happens if I truncate the top as well, right? If I take that edge and, oh, you know what? That won't work because it's not a polycurve anymore. I might want to go back to polycurves. That's all right. Don't worry about it. So anyway, if I pull that edge in, it's going to create something that's very, very different. Go like there. And the volumes, I'll fix that later. Actually, I'll just fix it now. Scale 1, go from here to there. And this one, scale 1, go from here to here to here. You guys don't have to do this right now. I just want to show you. But anyway, if I truncate it, then obviously rotating my floor isn't going to work anymore. So the objective is that I actually have to trim it. But the problem with trimming, as you all know, is that the geometry that you're trimming with has to be 100% trimmable, meaning that none of the geometry that we've created actually sticks out beyond the boundary of the thing we're trying to trim. You guys get that, right? More or less. You need them to be clean, fully encompassing. So the challenge for us is that first we need to make a floor plate that's going to always be larger than the volume that I'm going to use to trim it with. Does that make sense? So quick diagram on the board. If I'm going to trim this, whatever it is, I need to make sure that my platform that I'm trying to trim is always going to be larger than it. So we need to take this boundary and make it really, really big. I'm going to turn these off so we can start to understand what's going on. Okay. This boundary down the bottom needs to get really large. Then I'm going to extrude it up. Don't have to twist it or modify it at all, except to trim all of them by the outer boundary of my building. Massing. So first step is pull this away, and we're going to scale this thing. So I'm going to go to Transform, Affine, Scale, plug this in, and one thing that you probably want to do here is not scale it from the position, the origin, really. You need to scale it by a center point. So I always suggest the center point of itself. So I'll get area, plug my centroid into center point, and then all I need to do is just give it an absurdly large scale. So we could scale it like 3 times its original size, something like that. Making some sense? Yeah, sort of, kind of. Okay. I'll give you a sec to catch up. All right. So next step, right? We have our scaled floors. We're now trying to integrate this into our entire process. So you kind of know by now that if we plug it into, say, move, like that, what's going to happen is each of those is going to get moved upward. And all of that geometry is actually still being extruded, but we don't really want to have it extruded. We want to trim it, then extrude it. So I'm going to take that extrusion and move it over. You guys are starting to see a little bit more of the inner workings of my process here. I'll generally just do whatever I can to get kind of the idea, and then I'll just start pulling it apart and throwing things into the middle of it to get it to really be what I want. So anyway, before I do the extrusion, I need to trim it. Trim is going to act a little bit funny, but I'm going to go to intersect, and let's see, Brep. Yeah, Brep might do it, but we probably want surface. Yeah, Brep should do it because that's a surface. Yeah. Okay. So let's take Brep. It's this one right here. I think it will consider the surface to be a Brep in this case, but it doesn't always. So we're gonna take these here, and we have to trim it using another Brep, right? The problem is, if I plug these in, if I plug my surfaces in, that's these right here, each one is going to try to trim it separately, but that won't work because each one of them is not a closed surface. So I know I used a poly surface before, and then I exploded it, and then I put it back in here. It's really just a graphic thing that I corrected, but computationally it was intact and it was correct. But if you want to see it look a little bit better, you can do this, but you just need to remember to join it all together again. So I'm going to grab shape, and actually, it might just be join. Yeah, Brep join I think should do it. Plug that in. Yeah, cool. And that is located under surface and utility. Okay, so that creates one solid surface. I'm going to get rid of that here for a sec. So now that's one open Brep. At the top, it is not complete, so it's just a representation of my outer boundary. And I'm going to plug this into A, and I'm going to take my array of floor plate datum levels. Yeah, I think I'll call them that. And I'll plug that in here. Okay. Make sure you hide everything except for that. And what you're going to see are a set of curves that are representative of each of the intersections of that volume. Because they are curves, I just need to turn them into surfaces if I need them to be. So I'll just go to param, geometry, surface, and plug that in here. And each one of them now becomes a surface. And what do you think we do with that?
Extrude.
Yeah, we plug it into extrude. So I'll plug that in, I'll hide these, turn this on, and that's what I get.
Turn off what?
Just turn everything off except for the extrude. Okay, so what's great about this is that now, as a designer, I have complete fluidity over my skyscraper. In this case, it's more like a mid-rise, but I can very fluidly just grab this thing and yank it off to the side. I can twist it a little bit more. I can twist it a little bit less. Raising it up and down won't really change much except for the location of the volume. And notice here, when I pull it down, the number of floors just modifies to account for how many were there before the volume stopped. Does that make sense? So this is a completely fluid system, and it's going to be the basis upon which we start to develop our forms for our skyscraper. Okay? What questions do you have? No questions. You guys shock me. You're geniuses, all of you.
Thank you.
All right, you want to see one more thing before I close thoughts here?
Yes.
Each of these floors is, in fact, cutting through the core, and I want to point this out as something that's a concern when you get to kind of the end of the process. Let's pretend I've got this really awesome, cool building that I've designed, and I want to actually create drawings with it. Okay, so I grab all my geometry here and pull it off to the side, and I start to modify it like I want to create a section. Okay, you guys don't have to do this. I just want to show you what's going to happen. So let's create a cut plane, and select all of these. I'm going to cut it across here. Hit enter. Actually, yeah, I'll just do section, actually. I don't need the cut plane. Section. Grab those. Enter. There to there. Whoops, wrong view. Front view. Okay. This is what you're going to get. Okay. That is not correct, because we didn't subtract the volume for our elevator core from that. In reality, what it should look like is this. Okay, all the way down. Now, in this case, because mine is really simple, I can go through and do that really quickly and it's not a problem. But when you have a facade that looks like this, for instance, are you going to sit there and cut out all 100 floors or every single little framing element? You're going to go there and cut each one out that's not supposed to be there, or for, you know, for whatever system you're using, whatever the case. You just need to have some foresight about what you're producing in the end, because sometimes you can leave it the way it is. You can let the floors penetrate through the elevator core and it doesn't matter. Other times, you want to make sure you cut it out. And it's as simple as, go back to perspective here. Actually, let me get rid of those. Oh, whoops. Oh, shoot. Hang on. There we go. And it's as simple as just a subtraction. So I'm going to go to intersect, shape, solid difference, and I'm going to, I don't know, let's see. Thing you want to subtract with, the item you want to subtract, and then the item you want to subtract with. So that would be these, and then this one should go in there. I think that's the right way. I might have done it backwards.
No, you didn't do a B-rep off that one yet, right?
No, they're B-reps.
I mean the center.
Hang on. Let me hide this. No, it wasn't right. I didn't do what?
You didn't like select one.
You didn't set
B-rep,
that
right?
first
One of
geometry.
Yeah.
I didn't set what? Sorry?
You didn't set that. Whatever
elevator
that is, the
thing.
vertical circulation.
Oh, yeah. Gosh, you're right.
It's not one of the geometries.
Yeah, you're right. You're right. Sorry. I need to reference this. Sorry, guys. Long week. You know. Subtract that. And now, when I turn that off, you'll have a hole cut out. Let me flatten that.
Shall we do that?
There you go. No, you don't have to. I just wanted to show you it. Okay? So you won't have to do this. These two, you can get rid of those. I just wanted you to know that that's how you cut out the core. You can just do a subtractive process like that when you need it. Okay? And that simple two-component addition is going to cut out a tremendous amount of cleanup when you get to the drawing phase. Okay?
When you bake, after you bake it.
Yeah. Yeah. Anyway, let's get rid of those. Okay, I'm going to stop this video here, and then we're going to go into a couple other simple ideas.